The tree is one of the most basic, yet one of the most integral data structures in all of data science. A tree is basically a multi-level data structure that shows a hierarchical relationship between individual elements called nodes. First, we will be discussing the terminologies. The root node is the first node from where the tree originates. In any tree, there must only be one root node. The edge is a connecting link between any two nodes. If we look at the relationship between nodes, we can classify them as either parent or child. A parent node is a node that has nodes that branch out from it, and the children are the nodes which branch out from the parents. Furthermore, children can be called siblings if they have the same parent, and from this, the degree of the node is the total number of children of that node. Another way to classify the nodes would be by either external or internal. External nodes are nodes which do not have any children, and these nodes are found at the bottom of the tree. Internal nodes are nodes found within the tree and have at least one child. Yet another way to classify nodes is by their height and by their depth. The height of a node is the total number of edges that lie on the longest path from any leaf node to that particular node. The depth of a node is the opposite of the height. It is the total number of edges from the root node to that particular node. The level of the tree starts from the root being level 0, and increments by 1 after one edge, and making the leaves the maximum level. For the last few terminologies, a subtree is any parent-child relationship within a tree, and a forest is a set of disjoint trees. The focus for today would be a type of tree called the binary tree. A binary tree is a tree in which every node can have only a maximum of 2 children. The binary tree comes in 3 different types: the full binary tree, complete binary tree, and the perfect binary tree. The full binary tree is a binary tree in which every node has either only 2 or 0 as its number of children. The complete binary tree is a tree in which all levels are filled except for possibly the last one, and all nodes are filled in as far left as possible. And lastly, the perfect binary tree is a tree in which every internal node has exactly 2 children and all the leaf nodes are at the same level. Basically, it is a tree that looks like a perfect triangle. The last topic is tree traversals. Any node in a binary tree data structure can be reached by starting at the root node and repeatedly following references to either the left or the right child. This process is called tree traversal. There are 4 types of tree traversals: the level order, in order, pre-order, and post-order traversals. For an example, we will create a tree using the values 1, 2, 3, 4, 5, 6, and 7. The first type of traversal is called the level order traversal. Starting from the root, go down each level of the tree, listing each node from left to right. The level order of the example tree would be 4, 2, 6, 1, 3, 5, 7. The next type of traversal is called the in-order traversal, and it has the algorithm of left, root, right. The in-order of the example tree would be 1, 2, 3, 4, 5, 6, 7. It is important to note that in any binary tree, the in-order must always be ascending. The next type of traversal is called the pre-order traversal, and it has the algorithm of root, left, right. The pre-order of the example tree would be 4, 2, 1, 3, 6, 5, 7. And lastly, the post-order traversal has the algorithm of left, right, root. The post-order of the example tree would be 1, 3, 2, 5, 7, 6, 4.